Hey guys, this is Fred from Pretty Fly Games and this is episode 11 of how to build an online first-person shooter using Unity and Photon Fusion. I've been getting a lot of questions how to add third-person camera movement in Unity with Photon Fusion, so well, here's a video for that. To implement our third-party camera system, we're going to use Cinemachine, so let's install that. Go to Windows, Package Manager, and then type in Cinemachine. And select it on the left side here and hit install. So Cinemachine is a great tool for Unity to handle all type of camera movements for 3D and 2D. So let's just install that and then we can close it. And now we want to add our Cinemachine virtual camera to the scene. So let's go Game Object, Cinemachine and Virtual Camera. So that adds a virtual camera to our scene, and as we can see we got a little icon here, our main camera, which means that Cinemachine's brain has been installed here as a component, and we don't have to make any changes to this part. But we are going to make some changes to our Cinemachine virtual camera, and I find it easier often to add our player to the scene so we can look at, okay, what are we trying to configure. So here we have our player, and we are going to use our Cinemachine camera, and we are going to use a follow target and a look at target. So follow target and look at means that it's going to follow this target that we assign here, and it's going to look at the other target that we assign here. And in both cases it's going to be our network player. And actually, to be a little bit picky, it's not actually our network player, it's our model object. Alright, and this Cinemachine can run in whole heaps of different modes, but we are going to use one that I think is suitable for third-person camera. So we're going to start with the following part of our camera, and we're not going to use a transposer. We are going to use a framing transposer instead, and so this determines how the camera will follow our player, and we want it to follow behind our player but a little bit above the head of the player. So let's change our height of the camera to 1.3. And then we have some settings, look ahead time, etc. We don't need any of those, and we can leave all of the others for now. The other part is that we need our aim to work a little bit differently, because we want to follow from behind the player. So for this we are going to use something called POV, and that will set up the player's point of view to actually follow it. So if we go and look at our model here, and we can just for now disable our camera, then we can see that, okay, this is the virtual camera, this is how it will look at the player now, and it will actually follow the player around, and we just need to make some changes to it. And one of the changes that we want to make is to make sure that it's actually staying on top of sort of the shoulder of the player. And if we look at our scene view here, we have our camera, and let's just rotate our player to face 0 so it's correct, and then we can look at from the camera's point of view. So what we want is that our camera here is quite far away from the player. We want it to stay closer, and we have on our body here camera distance, so it needs to be more like this, 2.5. And then we want this camera not to be sort of straight above the player, but rather we want it to be a little bit on the side of the player. So we can change our X screen value here, and it should be something like on the side, so maybe 0.25. So that gives the ability to look over the shoulder of our player, and as well the Y, we can change that a little bit, so we come down a little bit, 0.3. And then we have some damping values, and the damping values is what makes the camera appear like smooth, and having a damping value in X and Y is all good, but in the Z value we don't want to have very much dampening, because then our dude will be able to move forward without the camera moving forward, and we want it to stay fairly close to the player. So let's change our Z damping to 0.1. And then we are going to as well change our soft zone. So the soft zone is this little green part here, and the camera or the person, the player, can move within this area without actually having the camera update. So we want to reduce that because we want it to be a little bit snappier. So let's make it 0.1. So you can move a tiny little bit without having the camera move, but not more than that. Okay, so those are the settings that we are going to use for for the movement part. And then the aim part, let's change this recenter target to look at target forward. So that means that, yeah, it's gonna look at the forward vector of our target. So when we are rotating, it will follow the rotation. And then we have some values here: input axis name, mouse Y, and that should be all good. And we have all the other settings that I think is going to work fairly well. And then we have the benefit of using Cinemachine is that it has a lot of features built in, so we can handle, for instance, collision. So if the camera now would collide with anything in the world, it would start clipping. And if we don't want that, we can add an extension for it. So let's add a Cinemachine collider, and the Cinemachine collider will react, and we can put in which tags or layers it should handle, like the default layer here. And so we'll keep it at default. And then we want it to actually have a minimum distance of 0.1, which should be fine. But we want the camera to be a little bit bigger in radius, 0.5, because then it will collide more. And then I like the pull camera forward because that is pretty good, I think, for FPS games in third-person camera mode, because it will bring the camera closer to our player whenever it collides, instead of going upwards or anything like that. And everything else, I think it should be okay. We can add some smoothing later on if we want. Okay, so that should do it for now. So let's actually delete our player, because I'm happy with this. And we of course keep these settings. So if we take our game for a little test spin now, we can actually force it to use this new camera. So let's just have our player start, and here we have our player. So let's disable our camera, and then we will enable our main camera, and then we need to configure our Cinemachine camera so it looks at the right thing. So let's have our target follow here, set it to our model, and then we are going to look at our model as well. So here we have our third-person camera, and yeah, it behaves a little bit strangely, because I mean we can rotate fully without the player actually following, but that's fine. So that's something we will fix later in our code. And we want to have the ability as well to change the camera mode so that we can swap between first-person camera and third-person camera in the game. Okay, so let's stop, and now we need to make some code changes. So let's start by changing our player a little bit. So let's go on the network and network player and open that in Visual Studio. So we are going to add a variable so that we know what camera mode we're in. So let's add a camera mode, and we'll use a public boolean is third party camera, and we are just using the regular get and set. So that becomes available for other scripts to read it, and well, also set that value. And as it starts, it's going to be disabled because that's the default value of this, so it's going to be false. And what we want to give the player the ability to press a button and then change that camera view. And to do that, we need to go into our character input handler. So we want to give the player the ability to press a button here to change our camera mode. So let's add after throw grenade here, let's add a new input. So in this case, we are going to say that, okay, if the key C is pressed, then it means that we want to switch camera mode. And what we have done is our sort of local version. That's going to be our network player. Local is third person camera, and we are going to set it to the opposite. So that means if it was disabled here, then it will be enabled, and vice versa. So that toggles our camera to be on and off, or toggles the variable to be on and off. Now, just toggling this variable won't make any differences. So what we need to do then is actually implement our change of camera, and we're going to use our local camera handler here. So let's open that, and let's have a look at the code for this. So we want to add a way for this to actually change our camera mode, and for that to work as well, we need to get access to our Cinemachine virtual camera, because we need to be able to turn it on and off, and also to be able to set the target, because remember, we need a follow target and we need a look at target, and we can set that from our code here. So let's add our Cinemachine to this. So another component here, there we go. I'm not really sure why we have moved this here. It shouldn't be there. Let's move it up so it becomes a little bit more clear, all the things we have. All right, and then I accidentally removed it. Oh no, I didn't, sorry. And then we need to make sure that we are using Cinemachine to be able to access that. So now we have that, and we as well need to make sure that we can manipulate this. We need to get the component, but we have a few cases here, which makes it a little bit complicated, because we have some scenes where we actually don't have a Cinemachine virtual camera. So we need to be sure that there is one available in that scene, and one kind of easy way to do it is to check if there is a Cinemachine camera. So we will do a check. If our Cinemachine virtual camera, our variable here, is null, then it means we haven't found one yet, and in that case we will try to find it. And if we have found it, then we want to make sure that we actually sort of use it and enable it and configure it. So in this case, we're going to check if we have a third-person camera enabled, and as well we are going to check if our Cinemachine is not enabled. So that means that we need to actually turn it on, otherwise it's already on and configured and we don't need to configure it again. And then we needed a follow target. So we needed to follow something, and we wanted to follow our player model. So, and then as well we need to have our Cinemachine camera enabled, should be true. And then let's have a look at the rest of our code, and so that should be fine. And then we don't want to do anything here, so we're gonna return. We're not. So let's just write, let the camera be handled by Cinemachine. Because this code here, we don't need it to make any changes to our camera, because that is all handled by Cinemachine. So that should be okay. And let's see what it says. It says that unreachable code detected, because I forgot the else statement here. There we go. So now we have the correct code. If the Cinemachine is null, then we're going to try to look for it. If it's not null, then we are going to configure it, and we're going to use it if it is enabled. And this part of our code is actually wrong as well. So I've been making a lot of mistakes here. So now it's correct. If our local camera is in third-person camera mode, then we are going to let our Cinemachine actually take care of handling the camera movement. All right, so that's good. Then we need to make sure that the Cinemachine camera is disabled if we are in first-person camera mode. So if we are not in this mode, then it means that we are in the first-person camera mode. And then we will make sure that we check, is there a Cinemachine camera? And if it's enabled, then we will disable it. So that will handle sort of the camera switching and the enabling and disabling of our Cinemachine camera. Now there is one more thing that we need to do, and that is we don't only need a follow target, we as well need a view target. So that means we need a look at target, and it's gonna be the same player model. Because the look at is required for certain things to work in the Cinemachine, such as collision detection. I think that the POV will work fine without it, but now we've covered our bases. So let's save this now and try it in Unity and see what happens. So let's take our game for a spin, and let's see what happens. All right, so this is the first person camera, and we can see that it's still working as it should. And if I hit C, then actually nothing happens. So when I'm trying to move now, nothing actually happens. So if I actually move out my game view here, so if I move now, we can see that actually our player is moving, but our Cinemachine camera is not updating, and our camera is staying still. So why is that? Well, it's actually because, remember I said before we needed to have the Cinemachine brain, and it's actually here on our main camera, but it's not active, and we are not using our main camera here. So we actually need a Cinemachine brain here as well in our local camera. So let's add that to our local camera. Let's paste it in. And now we can see that something happened. We can see that the camera is actually moving, and here we can still see our first person gun. But now as I move along, we can see that the view is at least working, but I don't see any characters or anything like that. So why is that? Well, it is actually because in the first person camera view, we have decided that our person here, or our model, should be in the layer local player model, which is not rendered by the camera. So if we change to default with all our children, then we can see that voila, here we have our character is actually there, and our camera is behaving like it should. So now we have a third person camera view, and we can switch back, and we can see that, okay, now I can see, well, my eyes and stuff, and I shouldn't, and as well here in the third person camera view, I shouldn't see my first person gun, but it is at least working. So let's stop that, and let's make some changes to our code so that it can work even better. And let's go back into our camera handler. So let's open our local camera handler in Visual Studio. So to get rid of our gun, our first person shooter gun, we need to be able to turn it on and off. So let's add a game object, public game object, call it local gun. And this is where we will fit in our first person shooter gun. And when we are switching our game modes here, then we want to make sure that we are also handling those parts. So if we look at, okay, we are enabled, and if we are enabled, then we need to take our gun and disable it, right? So let's see, there we go. And vice versa, if we are in this mode, in first person mode, then we need to do the reverse. So we need to enable it. And then we have these problems with that we could see ourselves, and in third person view we couldn't see our character. So we need to set our rendering layers. So we already created a function for that. So let's use that. So utils set render layer in children, and we're taking our player model and we're changing the layer mask to default. So that will make it visible by the camera. That's exactly the change that we did manually before. And if we do it on the opposite way, that we are going to disable it, then let's do it the other way around. So in that case, we are setting the layer to be local player model. So those changes should make sure that we can actually see our player and we can shift. So let's save that again and try it again in Unity. Then as well, let's copy our Cinemachine brain so that we have it in our prefab player. Let's open our network player, and let's try to open it again. Oh, we're not in CV. Oh, here we go. And let's find the camera, and here it is. So let's paste that in. Right, so then we have that, and our local gun, we need to have that. Here we go, gun, and then let's save, and then we can take it for a spin and see what happens. All right, so here we go, and let's switch camera mode, and yeah, third person camera is working. There are a few details, one tiny detail, and that is when I'm firing, which I'm doing now, nothing actually happens in our gun, because our particle system is instructed only to fire the local gun, which is not visible anymore. So we can change that code for that. That's easy. The second part is a little bit more complicated, and this depends on how accurate you want your game to be. So the thing is, my aim is not really correct anymore. So if I aim up here and I fire a rocket, it will miss. And the reason is we are firing from the perspective of the other camera. So it is firing from the center of our other camera, the first person camera. So if I switch to first person view and if I aim somewhere like there, it will actually go straight on. But if I do the same in third person view, it misses. And it's because there's an offset to it. So let me try to explain why in a different way. So we have our setup here. We have our player, which is blue, and we have some collider green, and we have our aim. So in a first person mode, it's fairly straightforward. We have our camera attached here, and we're shooting in the forward direction of the camera, and we're checking what we're hitting. But in our third person camera view, we have a bit of a different problem, because we are over here right now, or the view is here, and our aim is here. So we are on top of the player's right shoulder, and the gun is actually firing in the forward direction of where the player is facing. So that means that we have an offset, because we are aiming at this point, but we're going to hit this point. So how do we solve this? Well, it gets a little bit more complicated, but it's not that complicated. So what we will do is we will fire a ray from the camera's point of view and look at what does the camera hit. And once we have that, we're going to calculate another ray from where the player is to where we actually hit, and make sure that the gun is firing in that same direction. So that way we can ensure that we are actually hitting the same spot regardless of what camera mode we're in. Now, this is a little bit more complicated, and if you're happy with having this offset with the aim, and if your game is not that sort of precise, then you don't need really to do this. But if you want to have a perfect aim, and as well that the player sort of can't cheat, because otherwise if you're just firing from the third person camera, which you could as well, then it means that you can shoot around corners and things like that. So that's maybe something you don't want. But we're gonna look at this setup and how to add that in Unity. So we need to make some changes in our weapon handler to handle this. So let's open our weapon handler in Visual Studio. And if we scroll down, we will find the section where we are actually firing. So when we are firing, this code is executed. And if we look at the actual code, then when we are hitting something, we are actually checking that we are the state authority. So for us to be able to actually change this code, we need to tell the host authority, that is the host or the server, that we are using this mode, because otherwise this part of the code is being executed on the server side or the host side. And it means that right now, when we are making our change here, we're changing, network player, when we are changing our variable here is third person camera, we're only doing it locally. We're never informing the host that this has happened. So this is the first part. We need to inform the host that it has happened, so that we can later on act in the weapon handler. So the only way that we can tell the host something is either through our networked input variable or send an RPC. So we are going to send an RPC because we're just going to do this a few times, not that often. So I don't think it should be in the input networked variable. So instead we are going to trigger an RPC call. So let's scroll down, and I think we already have some RPCs. Here we go, set nick. So we'll add another RPC. Just in the same way that we have done with the nick, we are going to send from the input authority, and we're going to send it to the state authority, and we're going to call this RPC set camera mode, and it's going to be a is third party camera. So this will be received on the host side only. So let's add just a debug so that we know that it has happened. And then we want to set the variable on the state authority. So this is third person camera, and set it to the variable that we receive. Okay, but this needs to be sent somewhere. So it means that when we are actually getting our input key press here, then we need to as well handle this part. So let's open our input, and when we are getting our C pressed here, we need to tell the network state or the state authority what it should be. So in this case, we're going to use the network player local triggered RPC with the value that we have here. So now the host as well knows about this. And we don't have to make this into a networked variable. So the reason why is because, well, we don't need to tell anybody else about this. So it doesn't matter for another client which aiming mode we're in. If it does for some reason, then you need to change it to a network like here. In that case, it will replicate to all the other players as well. But for now, we are just going to leave it as it is. And let's go into our weapon handler again. So now we can check our code here and see that, okay, so our fire is taking our aim forward vector. So the aim forward vector is coming from wherever we are pointing sort of our aim, right? So that, if we look at the code that we needed to actually implement, was that we needed to fire a ray from the third person's camera point of view. And right now, the host does not really know where the third person camera is. So that is something we need to actually provide to the state authority so that it actually can perform this shot or the raycast. So let's start by adding it in the network. So we needed to add it in our networked input variable. So input data struct. Here we go. So after our aim forward vector, we're going to do a camera position, which is going to be a vector 3, and then we can save that. So now we need to supply that information. So let's go into our character input handler, and in our input handler we need to update the information. So let's add our camera position after our aim data. So we'll do a network input data, camera position, take our local camera handler transforms position. So then we are getting the local position of the camera, so the client's position of its camera. We're sending it to the server, the host, so it knows how to perform the shot or the raycast that we will do. All right. So now that we have this information, we need to as well supply it with our fire input so that we can actually access it here. So let's add that camera position, and once we have saved, we can see that, okay, we have an error here, and the error says that, okay, we need to supply the parameter, which is expected. So let's just supply the parameter. So network input data and camera position. Okay, so now we have gotten rid of that error. Then we need to determine what sort of camera mode we're in. So let's check our variable and say that, okay, network player, is it a third person camera? If it is, then we will do some special stuff, and if it's not, then we'll do something else. But let's start with the case where we are the third person camera. So in that case, we want to perform a raycast to figure out what the camera is hitting. What is the third person camera aiming at, and did it hit anything? So we will do a raycast as we did before, but from the camera's position. So we'll use the camera's position, and the direction is going to be the aim direction, but we're going to change the variable a little bit to make it easier to actually replicate this. So after we've added our fire effect, let's add a variable called fire direction. And at first, our fire direction is just going to be in our aim forward direction. And before we had a variable called max distance 100, and now we actually need to be a little bit more specific about that. So let's add that as a variable so we can actually control it in a more easy way. So let's go to the top of our code, and we will add a suitable place, last fireplace, here we go. Let's add max distance 200. So we are actually going to shoot a little bit further than we did before. So maximum distance is 200. And what we will do then in our code for this is that we are going to declare a variable called hit distance, which we as a default set to max distance. So this is actually the variable that we had here, so we can get rid of that. And then we will use this. And the reason why we are doing this is if we're firing at something that does not exist. So think of it this way. Your character is running around on the map and they are firing into the sky. In the sky there are no colliders, so it means that this will return false. They didn't hit anything. But we still need to use that information when aiming, because if the player decides to fire, let's say, a rocket into the sky, then we want it to sort of go towards the aim. So we will, in that case, assume that since we didn't hit anything, the actual, or then we fake it and say that it did actually hit something at the max distance. So, but we'll come into that a little bit later. So, and then the next part is going to be similar. So we have our object input authority that should be included. And then we are going to provide some hit information. And same here, we are going to actually create a variable for it so we can reuse it later. So let's do a hit info, and we'll call it, or a new lag compensation hit. And let's provide that. And then we are going to have our collision layers and then the options. And while we are actually looking at our code here, I see that we have a bug here. So right now we are looking at the hit options, ignore input authority, which is fine. That's that we are ignoring ourselves. But at the same time, we are not hitting anything else. So it means that if somebody is hiding behind a box, which is going to be a physics collider, then we are ignoring that. So it means that you can get shot through obstacles. So we need to include our hit options, include physics. So by using this sign, it means that it's this and that. So both of them. Or actually it's this or that, sorry, not both of them at the same time. And we need to say that it's an out. Okay. So that will perform our raycast here. And then we will see that, okay, what did we hit? Did we hit anything? So the first thing we need to check is if we hit another player. So let's check that. And other players will have a hitbox, other objects will have a phys-X collider. And if we did hit another player, so now we're firing the ray from the camera, then we need to calculate a direction from where our sort of gun or wherever we're firing from. So we need to calculate what direction should that weapon or other firing point have in order to reach this point. So we will calculate a new fire direction, and we will take the point where we hit something, and we will subtract our aim point, wherever that is, and we will normalize it. So then we get a fire direction. And then we have a distance. So we want to figure out, okay, how far away was the object that we hit? And we are doing that by getting our hit info distance. Okay, so then we want to as well draw some kind of debug information so that we can see what is actually going on. So let's do that. So we'll draw a ray from our camera's position in the forward direction, or actually we could use fire direction, but in this case we're overwriting our fire direction, so let's use aim forward here. times distance, so that we get the correct length of whatever the ray should be, and then we'll provide a color and we'll make it slightly reddish but not full red, and then it will last for 1 second. That's how the duration of this ray is going to last. Okay, so then we have that sorted. The other part is we are going to check if we hit some PhysX collider, and in that case the hitbox is going to be null, but the collider is not going to be null. So in that case, let's just see, did we hit any other PhysX collider? And we do the same thing, same actual calculations. We could actually move all of this into this code here, but for now I'm going to leave it as it is, as it may be easier to understand. And then we will do another debug ray here, and in this case we're going to use a color which is slightly green, so that we can see what is going on. Okay, and then we have the case that we didn't hit anything else at all, so we are firing into the sky or whatever. And in that case, let's use a gray color, and in that case we need to set our fire direction as well. So our fire direction in this case is going to be from wherever our camera is, plus the fire direction, so from our camera's point of view position, plus the fire direction, times our hit distance, minus our aim point position. So that will give us the fire direction in this case. And as well, we should actually normalize this. So normalized. Then we will have that fire direction as well. So now we are going to redo this code. So if a person has fired with third-person camera, then we will get a hit point of where it hit and also a fire direction. And if we're firing from the first-person camera, then this will be essentially the same. But now we want to use this information that we got in our code here. So let's actually redo our code a little bit. So let's first of all reset our hit distance, because right now we already have our information, so we can reset our hit distance, which is going to be our max distance. So in this case we are just saying that it doesn't matter what information we got here about the distance, we're going to reuse the max distance anyway. So then we are going to remove this part of the code and just keep writing. So let's redo the same thing. Raycast from the aim point's position in the fire direction at the max distance with all the parameters that we had before, including the PhysX in this case. Okay, so then we redo sort of the same hit check again. Did we hit the player? First of all, and if we did hit a player, what are we going to do? Well, first of all, let's update our hit distance, and then we are going to check if we are the state authority, like we have done here as well, if we are the state authority. So let's do that. If we are the state authority and we are getting a hitbox, then issue damage to whatever we hit, get the component, HP handler, on take damage with information about who shot who. Okay, then let's add a debug array for this so that we know that we have hit something. So we'll do a draw ray from the position of the aim point in the fire direction times the hit distance, and it's going to be full red color. Okay, then let's do the same check again. If we didn't hit a player, then we might have hit some PhysX object. So let's update the hit distance, and let's do a debug draw ray here as well, and use color full green. Okay, and then we had the last case if we didn't hit anything at all. So let's add that as well. Draw ray, aim point, position, fire direction times hit distance, and color black. And then our code is going to be, okay, the last thing we do here is last time fired equals time. So we can get rid of all of this code because we have replaced it with the new code. Now, that was maybe a little bit complex, but hopefully it will become more clear when we run the code. So the other thing that we had was when we were firing from a third person point of view, then there was no fire indication from the gun. So let's look at our code for that. So we have our is firing true, and then we are using fire particle system and play. So what we will do is we will check if we are in third person camera mode, and in that case fire particle system remote play, and otherwise we are firing our local system. So that will solve that problem as well. So let's save that, and now we can try this in Unity and see what happens. So let's move our game view and put it down here so that we can look at both of the screens at the same time. And then when we have spawned, let's make sure that we're in view. All right, so here's our character, and I'm going to shoot at the right corner of this. So as we can see in the main view of our scene, I'm shooting on the top right corner of this collider, and we have a full green solid hit. So that means that it actually worked. If I fire into the sky, we have a black array, which means actually I didn't hit anything. So let's change into camera, third person camera view, and look at the same thing. So we'll fire at the top corner, and as we can see now, actually I'm gonna see if I can zoom in. So let's zoom in a bit. So if I fire again, we can see that, okay, we have a green, a fully green ray coming from the character, and then we have a little bit lighter shaded green coming from the camera. So what happens is that the camera is first doing the ray, or the follow camera is doing the ray, which is the lighter ray, and wherever hit, it will do the other ray, which is in the full green. So I hope this becomes more clear now. But we still have the problem with the rockets, is that they are not aligned. So if I'm standing like this and firing, then I should have hit that corner, but I didn't. But I can hit it with my gun. So we need to change the code as well for our rocket. So let's do that. So our rocket will actually be using exactly the same code as this. So instead of rewriting the code twice, let's make a function out of this. So we will take our code here, like compensated hit, and get rid of essentially all of this. And then let's create a new function, and let's create void calculate fire direction, and it needs to take in a vector 3 aim forward vector, and vector 3 camera position, and out is going to be vector 3, and we should call it fire or direction. Okay, actually let's call it fire direction. So now we have all of this, and let's just delete our declaration there, and let's just review our code, and no errors, which is good. So in this case, let's do a calculate fire direction, and provide the aim forward and the camera position. And we need to get our out fire direction. So now we could call this function and we want to reuse it for a rocket, but this also deals damage, so we need to get rid of the damage dealing part in this. So instead of returning a void, we are going to return whatever we hit. So we are going to return an HP handler. So here we go, hit info, and then we'll return. Actually, we need to store this as well. So let's do a HP handler. HP handler. And HP handler is going to be R in this part. So we're getting the component from the hit info from the hitbox, and then we are going to do our on damage. And do that part, and then we are going to return our HP handler. And actually we want to have our draw debug still there. Okay, so that's all good. And if we didn't return here, it means that we missed everything. So let's return null in that case. Okay, so actually this shouldn't deal damage, right? It should just get our HP handler. All right, so my mistake. So now once we have fired it, let's add a variable here, hit HP handler, hit HP handler. If hit HP handler not equals to null, and object has state authority, then let's deal some damage. Okay, so now let's do the same thing with our dear rocket. So the rocket fire code is here, so let's do that. Oh, I could actually grab the whole thing. Hold on. Fire rocket, here we go, and we need our code for that, vector 3 camera position, and out is our fire direction. So spawn rocket prefab, and from the aim point position in the aim fire, which is going to be our fire direction, and as well the camera is going to look at the fire direction. So there we have it. That should also resolve our fire rocket problem. And let's add our camera position here. And actually I did do a little mistake when I think about it. And so right now we're calculating our fire direction, which we have misspelled as well. Hold on, direction. So let's make sure that it's correct. And then so what we have now is, okay, we're doing fire, starting the fire routine. We are assigning our HP handler, hit HP handler. We're checking that it's not null, and then we are doing damage to to HP handler, which is not our hit HP handler. So let's make sure that we are using the correct one. And in here as well, we have our calculate direction fire. And if we look at a code, it's actually using the same name here, so it's not super good to use HP handler because it's already used up here. So that will cause some hiding and it won't function properly. So let's make sure that we are actually using a new variable for that. So that was a little bit lazy from my side. So let's do a hit HP handler there, null, and then we are going to use that and return the hit HP handler and return null. Okay, so now we can save that and try it in Unity. So let's move into the correct place and let's fire at the top left corner, and we can see that the ray is hitting, and in third person view we are still hitting, and let's do the same thing with a rocket, and now it's actually hitting the correct target. So that's awesome. Now our third person camera is actually working, and yeah, we saw some clipping there through the face, and yeah, that could happen, I guess, if we get too close to the player, which is okay for now. So there, while testing this, I actually noticed some other errors that I want to bring up, and they are caused by the client, so being in the client mode. So let's have a quick look at the run this as a client instead and see what happens. So let's actually open our menu first of all, and now I've started up another server. So our server is running, and we're gonna find it and become a client. Hold on. So find game and test client. Let's join that. So the first part is this stuff are rotating, and well, it shouldn't be like this, right? So that's something that we need to fix, and then let's have a look at another problem, and let's just ready up and start. So here we go, and we are now started, and we have some errors. So there are a couple of things: object reference not set to an instance, and some null reference problems. So let's actually have a look at one by one. So let's address the first one. Let's open our Ready UI handler and see what is going on here. So the first error we had was caused by the network player local not being set yet. So this becomes sort of a race condition where our update code is expecting the network player local to have been assigned, but this code is actually executing before this happens. So we need to add a check for that, and it's quite easy. We will just check that if it's null in the network player local, then we will return. So that will solve itself, because when it has been assigned, then it will start work. Okay, so that was problem number one. If we look at our funky character rotation, then we have our fixed update here. We're getting some information from the network, and we're doing some movement and rotation. And what we will essentially say here is that it doesn't matter on the fixed update on the network. We will actually not touch it if the scene is ready. So if we are running our ready scene, then we are not going to move the character. We are happy with the position that it's spawning at, and we're not going to move that. So that will sort of remove our funky business of moving and spinning and things like that. And yes, we need to use Unity Engine Scene Management. Okay, so that was the second problem. Then we had another error here in network player, and it happens because when we are loading the world scene from ready scene on the state authority, we are preserving the objects, but on the client side everything is getting recreated from the network's player's point of view, so they will get actually destroyed, but then this part is actually still called. So we need to make sure that if we are getting our on destroy, then let's actually unsubscribe to on scene loaded. And we actually have the same scenario in the character outfit handler. So let's add that as a fix for this. So let's add on destroyed here, and then let's unload or unsubscribe to on scene loaded events. Then we actually do have one last problem, and that's our network player. So when we are spawning our local player, the nickname of our local player is shown for ourselves, and we didn't notice this when we are in third person view. Well, we're in first person view because it wasn't visible, but in third person view we can clearly see it. So let's make sure that when we are spawning our local player, that we are as well disabling our name for our local player. So let's save that, and now we can try it in Unity. Alright, so now we can try our fixes, and hopefully they will well, have worked. So let's find our game and join, and let's ready up the host and ready up myself, and then we are in the game and we can move around as before, and let's see if we can shoot. Yeah, we can shoot the host. Switching to camera, third person camera, and we can still shoot the host, which is good. And I don't see my name anymore above my head, which is nice. I can also, well, fire rockets. So let's see if they are hitting the correct position, and yes, they are. And let's just fire into the sun and see wherever it goes. So that's close enough, at least. So yeah, that's it. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. This concludes this episode, and I hope that you enjoyed it. If you did, please give it a thumbs up and hit that subscribe button and the bell to get a notification when the next video is out.